Tanks! They're some of the most fearsome vehicles ever built. Weighing over 60 tons, firing massive guns, and rolling straight through terrain that stops almost anything else. But one question always comes up. How does their armor actually work? Today, we're breaking it down in the simplest way possible. From basic steel plates to explosive bricks and high-tech composite layers that can stop jets of metal traveling at thousands of meters per second, this is the full story of how tanks survive on the modern battlefield. Let's start with a simple idea. Tank armor is all about putting something strong between the crew and incoming fire. But it's not just a matter of making the metal thicker. Early tanks in World War I used plain steel plates, but that changed fast. Modern tanks use armor that is layered, angled, composite, and energy-absorbing. The real goal isn't just to block. The goal is to defeat its energy. Armor designers think about how to make incoming fire waste its power before it can reach the crew inside. That energy can come from kinetic impacts, like long-rod penetrators, or the explosive force from shaped charges, shrapnel, or even the blast pressure from mines. And every threat requires a different kind of armor, which is where tank design gets really clever. Before composite armor existed, tanks relied heavily on angled armor. When you angle a plate of steel, two important things happen. First, the effective thickness increases dramatically. A 100mm plate angled at 60 degrees acts like it S, almost double that thickness to an incoming round. Second, angling makes it much more likely for a projectile to deflect or ricochet. A round that hits at a sharp angle might just skip off instead of digging in and penetrating. Cold War tanks like the T-55, T, Lokujuni, and the early Patton tanks used angled armor to squeeze out as much protection as possible without adding extreme weight. And even today, the geometry of the armor is still a major part of tank survivability. The shape of a turret or a hull can be just as important as the materials it's made from. But then, everything changed with the invention of composite armor, especially the type famously known as Chabham armor. Developed in the UK back in the 1960s, this armor is a layered sandwich made of ceramics, special metals, high-strength fibers, and sometimes even empty air gaps. Each layer has a specific job. The ceramic layers are extremely hard and can shatter an incoming penetrator on impact. The metal layers behind them catch the fragments and absorb kinetic energy. Elastic or composite materials stretch and deform to soak up the impact. And those air gaps, they're designed to force the super-fast jet from a shaped charge to expand and lose its power. The key idea is simple. No single material is perfect, but when you combine multiple materials, they can work together to defeat even the most advanced weapons. Composite armor doesn't just resist penetration, it actively breaks, slows, and destabilizes whatever hits it. So let's talk about one of the most dangerous threats to a tank today, the APF-SD's round. That stands for armor-piercing, fin-stabilized discarding sub. It's basically a long, thin dart made of tungsten or depleted uranium, traveling at up to 2 kilometers per second. It doesn't explode. It just punches through armor using pure, brute force kinetic energy. So how does a tank stop something like that? Well, that's where the composite armor sandwich comes in. The hard ceramic layers at the front are designed to break the very tip of the dart. The layers of composites and metals behind it bend and flex, destabilizing the long rod and making it wobble. Finally, dense metal backplates absorb whatever energy is left. Some tanks also use a special kind of armor called non-explosive reactive armor, which flexes outward on impact to interrupt the dart's path. The point is, modern armor isn't trying to be harder than the dart. It's trying to damage the dart and make it fail before it can do its job. Now, for another major threat, the heat warhead, which stands for high explosive These weapons don't rely on speed. Instead, they use a shaped charge-an explosive with a hollow cone of copper at the front. When the explosive detonates, it collapses that copper cone into a super-fast, super-hot jet of molten metal. This jet can reach speeds of several kilometers per second, easily burning through steel like a hot knife through butter. So, how do tanks stop it? Again, the composite sandwich helps. Ceramic layers break up the jet. Air gaps force it to spread apart instead of staying focused. And other materials absorb the extreme heat and pressure. But the biggest game changer against heat rounds is something called reactive armor. You've probably seen it? It looks like bricks or tiles bolted to the outside of a tank. This is explosive reactive armor, or ERA. Inside each brick is a metal plate, a thin layer of explosive, and another metal plate. When a shape-charged jet hits the brick, the explosive layer inside detonates outward. This blast slams the metal plates into the incoming jet, disrupting it and stealing away its power before it can ever reach the main armor. ERA can even help against kinetic penetrators by knocking them off balance. However, ERA has its downsides. The bricks have to be positioned carefully. They add a lot of bulk to the tank, and the explosive blast can be dangerous to any friendly infantry standing nearby. But its incredible effectiveness is why so many tanks around the world still use it. Of course, not all reactive armor is explosive. Some tanks prefer what's called non-explosive reactive armor, or NERA. Instead of explosives, it uses flexible materials like rubber sandwiched between metal plates. When a projectile hits, the inner layers bulge outward, disrupting both shape-charged jets and kinetic penetrators. It's much safer for nearby troops than ERA, requires less maintenance, and works extremely well when combined with the main composite armor underneath. But these days, armor alone isn't enough. The threats are just too advanced. That is why modern tanks also use active protection. Systems detect defenses that intercept incoming threats before they even touch the tank. Systems like Trophy, Arena, and Iron Fist use radar to detect incoming missiles or rockets. When a threat is detected, the system fires a countermeasure like a small spray of projectiles to destroy or deflect it in midair. Think of it like a tiny, personal air defense system installed right on the tank. There are soft kill systems that use lasers to jam a missile's guidance, and hard kill systems that physically shoot the threat down. An active protection system doesn't replace armor, it adds another crucial layer of defense on top of it. We also have to consider the underside of the tank. This has historically been a critical weak point. Mines and IEDs create massive upward blasts that older tanks struggled to survive. Modern designs now use V-shaped holes to deflect that blast pressure away from the crew compartment. They also have thick underbelly armor, energy-absorbing seats that prevent the crew from being slammed into the floor, and blast shields around the fuel and ammunition storage. The bottom of the tank is specifically engineered to survive vertical blasts, not just horizontal fire. Finally, even when armor successfully stops a round, something dangerous can still happen inside the tank. It's called spall. This is when fragments from the interior face of the armor break off and shoot across the crew compartment at deadly speeds. To prevent this, tanks are fitted with spall liners, which are usually made of materials like Kevlar. These liners act like a catcher's MIT, catching those deadly fragments before they can reach the crew. It's the final layer of defense, just in case everything else fails. So, how does tank armor actually work? It works because it's not just a thick slab of steel anymore. It's a combination of engineering, physics, chemistry, and smart design all working together. A modern tank is protected by angled steel, composite materials, ceramics, rubber layers, explosive bricks, non-explosive panels, active protection systems, spall liners, and blast-resistant floors. Every single layer has one purpose: to buy the crew more time to survive. That is how tanks stay alive on the modern battlefield. That is how tank armor really works. Thanks for watching. If you found this interesting, be sure to hit that like button and subscribe for more deep dives into military technology. Let us know in the comments what you want us to cover next.